So one person, what is the reciprocal of number 1? David. That's what we have there. Y squared over 3x. Okay, for number 2, someone. X plus 1 over x squared, or x to the second power, that's fine. And our third one, the hand up. Third one. Someone like to give us the third one? Yes, ma'am. Yes, x plus 4 over x squared minus x plus 6. We find these reciprocals. Now, why are we worried about these reciprocals? Well, we have to think about how we divide. How we divide fractions. Okay? A little review of how we divide fractions. Remember, if I have 3/4 divide by 2/5. No, I don't simplify. I can't simplify right now. What I would go is 3/4 times 5/2. Like that. And since we can't simplify, we end up with 15/8 like that. Over here, I have 4/7 divide by 8/21, which would look like this. Divide by 8/21, which becomes 4/7 times 21 over 8. Now this time I can simplify before I do that. And I get 3/2, like that. Reviewing. So to divide fractions, you do what? You multiply by the reciprocal. We multiply by the reciprocal. Like that. Shh. Which one? This one? Well, 4 and 8. 4 divided by 4 is 1. 8 divided by 4 is 2. 21 divided by 7 is 3. 27 divided by 7 is 1. We simplified before we started. Shh. Now, when we divide rational expressions, we do the same thing. You're going to multiply by the reciprocal and then simplify. So if I have this problem here, I have 8n to the 5th over 3 times 9 times 2n squared. So that when I simplify, well, 9 and 3, what is the greatest common factor of 9 and 3? 3. So my 3 divided by 3 is 1. 9 divided by 3 is 3. 8 and 2, what's the greatest common factor? I have a 2, which becomes a 1. This becomes a 4. N to the 5th divided by n squared means n 5 minus 2. So that becomes a 1. This becomes n to the 3rd. So I get 12n cubed. Actually, I'm going to write that down below, get it out of the way. 12n cubed, like that. Any questions about that? Pardon? No, because the 12 is on the top. 4 times 3, n to the 5th divided by n squared would be n cubed. They're all on the top, not on the bottom in this case. So, if I was looking at this one, this would equal 2x plus 8 over 9, we need to hush please, times 3 over x plus 4. The one after the division sign. Shh. Sam. Daniel, did you not learn? Erissa, you can take Jeff's place outside, please. You want to be everybody's lawyer. I don't like lawyers. Now, someone have a question?
Can I use the bathroom?
No. Shh. Now, we need to basically factor out things before we can simplify. I can factor out my 2 here, so I get 2 times x plus 4 over 9 times 3 over x plus 4. And now I can do my simplifying. X plus 4 and x plus 4 cancel out. Well, 2 and 9, they don't go together, but 3 and 9 have a greatest common factor. We get a 1 and a 3, which means my answer here is going to be 2/3, just like that. Yes, ma'am.
How you put x plus 4, but didn't you divide 4 times 8?
Remember, these binomials go together. The numbers go together. They don't, they're locked together.
When we divide them, the 4 doesn't change to a 1?
No. Well, that is a 1. But I'm not worried about putting it. We understand it's a 1.
But you have 4 right there, so 4 can take out the other 4.
No, I have an x plus 4 and an x plus 4.
I know, but shouldn't it be an x plus 1?
No, because it's the binomial that's canceling out. This x plus 4 and that x plus 4 cancel each other out.
Didn't you divide that 4 with that 8?
No. I took out a 2. I factored out the 2. That's where I got the x plus 4. I factor out a 2. Alright, so you guys, using it as a guide, do these 2 problems, please. Do number 3 and number 4, please. We have, I really need to be quiet, please, times x plus 3 over x plus 1. Now remember, the binomials are locked together. All these things are locked together. You can't divide them up in and of themselves. But this binomial cancels that binomial, leaves us with x plus 3 over x plus 2, which is our most simplified form. And most of you got this one. This one over here is giving you trouble because you're not factoring. You're going to have to use that diamond box thing. Shh. Remember, you can't... Both of you. You can't just say, oh, an x squared and x squared. No, they go together. It's the whole trinomial, the whole binomial. You can't just take out bits and pieces. I mean, if they're all multiplied, you can do things like that. But we have multiplication and addition together. So I get my x plus 1, x squared minus 1, times x squared minus 2x plus 1 over x plus 1. You have to actually factor both of them.
You can't take x plus 1 plus 1 and x plus 1 out?
We can take that out. We'll do that in a second. But because I have quadratics here, I need to see if I can factor both of them. Now this one, you may not recognize this one as one of our special rules. So we'll use our diamond box to show that. This one you should be able to recognize as one of our special rules. It's the difference of 2 squares. So this one would become x minus 1 times x plus 1, like that. We'll save that for later. What?
Isn't it the 2 is supposed to be on the outside of parentheses, isn't it?
What?
X times x minus 1.
What are you talking about?
Saying x parentheses x minus 1.
It's x plus 2x minus 1.
X squared minus 2x plus 1. X squared minus 1. What? Yeah, it's the difference of 2 squares.
Yeah, I got it right
guys, okay, I will do the diamond box for that one. We'll do the diamond box. Shh. I really need you to be quiet. You guys really need to study. This was like section 6.2. This was chapter 6. This is like the second section in chapter 6. Talked about these. But we'll diamond box it. I have -1 and 0.
How do you know when you're going to do a diamond on box?
Well, that's how, if we're going to factor one of these quadratics, we use a diamond box. 1 and 0, because there's no x term. Which means I have 1 and I have -1 as my factors. 1 plus -1 is 0. So that when I did the box part of it, x squared, -1. X, -x. I have a -1 in x. X and +1 becomes x plus 1 times x minus 1. Just like that. But like I said, you should be able to recognize the difference of two squares. We have that's one of our special rules. It's going to be the square root of 1 plus the square root of the other, square root of 1 minus square root of the other. And I would appreciate if you look this way and not start talking to David as soon as we get done. David, you need to be quiet too. Now, so that gives us this by that particular quadratic. The other quadratic we also need to box and diamond. We get +1 and -2. So that's either +1 and -2 or -1 and +2. Excuse me. Sorry, wrong. Shh. Okay. We can all stay a couple of minutes. All right, +1, -2. So our factors of 1, we either have 1 and 1, -1, and -1. Which one is it going to be? -1 and -1. So that when I do my box, I get x squared, +1, -x, -x,
Why do you put
-1x. So I get -1 and +x, negative, I get positive x, positive x, and -1. Because the only way, if I have a negative up here, the only way I can get a negative down there is multiply them. So I get x minus 1 times x minus 1, which would be x minus 1 squared. But we don't write it like that because it can cause confusion. So, when we write it all out again, shh. See, this is very helpful when you just keep your mouth shut and let me finish and then ask questions. And pay attention. But you're too busy talking to each other. That's why you get confused. So we have our x plus 1 over x plus 1 times x minus 1. That's this first one. Times x minus 1 times x minus 1 over x plus 1. All right, so we have the factor of the top term over the bottom term. The top term over the factor of the bottom term. Now we can start putting some of our simplification. This x plus 1 is going to cancel out that x plus 1. This x minus 1 is going to cancel that x minus 1, and it leaves us an x minus 1 on top and an x plus 1 on the bottom, just like that. Shh. So once again, this way with mouths closed. When we do the reciprocal, we have to factor this one. Now whether you remember it's the difference of two squares or we do our diamond box, we still come up with x plus 1 times x minus 1. we have to factor the top one. Now this is a number squared, but if you don't recognize that, we still did our box. We ended up with x minus 1 times x minus 1. We put them all together and we simplified. Yes, ma'am.
Does it matter in what order you put it? Like x minus 1?
It could have been x minus 1 times x plus 1. Mary, multiplication is cumulative. Yes. David, you had a hand up.
Oh, for the two sets, for the second part, I put x plus 2 and x minus 1.
For this one?
Yeah.
That's wrong.
But you're still getting negative 2 and positive 1.
I'm telling you, it's wrong. This, then you foiled wrong, because this is going to give you the negative 2 and the positive 1. If you had a plus and a minus, if this was a plus and this is a minus, it would look like this. David. If this was a plus and this is a minus, it's going to be this, not that. When you have a plus and a minus, you end up losing the middle term. I mean, that's why we end up with things like that.
Mr. Reese?
Yes.
I was gonna ask, how come there's a x plus 1 when we minused it? I mean, okay, never mind, I get it.
We factored out a positive 1 here. We factored out a negative 1 up here. Remember, negative 1 has a factor of positive 1 and a negative 1. I can't factor out 2's. All right, so you guys try these two. Try those two.